flipped half the diodes around. On the top half of the dual RPS, the bottom half is still both common negative on this end with the Darson valve configuration over here, Darson valve configuration up here. Positive is coming out to this side over here, and I flipped this series of diodes over, and the negative comes out on this side. So now it's 100,000 volt total potential that can be gapped here, and that's just so that I can make the gap as wide as I want, and it'll still eventually arc over. I'll turn it on, let it run for a quick second, make the gap as big as I can. That one, right? And I'll show you a weird effect. So it'll run, it charges up, it discharges, starts making the noise. After I shut it off though, there's an interesting effect where if I short that gap, there's power left in the system there, and it almost arcs the screwdriver head to the actual electrode. So I'll just show you so you can see what I'm talking about. Alright, and then with it like that, I just bring a screwdriver over here and I use that to bridge the gap, right? Get this at a good angle where it's going to be good and visible. You hear that? It's even squeaking. Do it one more time. Somehow that tank is retaining charge after the system's shut down. And how much charge depends on how long the system is running. Let me let it run for a minute real quick. Alright, that's about a minute. And I'll short the gap again and show you this. You can actually hear the AC run caps are popping from the charge that's back suppressed into the network. So there's some kind of a buildup of power. And the bottom one is pulling negative to negative. This one is positive to negative on top. And you saw how it pretty much just pulled an arc there when I shorted that over on the tip of that screwdriver. So I have to think about that and see exactly what's going on. It's got to be some kind of a, I don't know what it is. It's got to be something, because something's there. So I guess we'll have to figure out how to try and get a scope near the system somehow and see if it's maybe got some kind of leftover ringing charge, right? Because that was kind of the point of setting up the Darson valve on this side, was the capacities act to isolate the coil from the actual discharging capacities over here. This is 550 PF, 96,000 volts, 500 PF, 550 PF, 96,000 volts. Or sorry, I said that wrong. So it's total 550 PF for the full string at whatever 96 times 2 is. What is that? 172,000 volts. These are actually 550 per string, so that's 1100 per NF on this side with the two strings in parallel, 1100 on that side, and that's why it's 550 total. These are 133, they're the same caps, but these are two in series, so you're at 1.6 NF, and then divide that again for the other two on the other side, so that's 800 PF, right? So the difference now, though, is that because it's set up with a negative on this side and positive on that side, this cap could go back to being the big 25 NF cap on either side, which would be 12.5 NF total. And this is still going to keep firing because it's set up for the 100,000 volts to be present instead of the two positive or the two negative connections as the gap, which only gives you a range of about 1,000 to 10,000 volts, somewhere in there. But this type of effect where there's energy left in the system that moves or wants to move in that kind of oscillatory pattern as the discharge is set up to be able to occur, that's something that came out of the Bolerian apparatus work with the original triple coil set. Anyway, we'll have to see how it goes or where it goes. Something else to note.